One of the biggest reasons that we complete the square for quadratic is so that we can put the quadratic in vertex form. And vertex form is awesome because it obviously, again, as a reminder, just gives you a way to graph because you have the point that is the vertex, and you can, look at the horizontal and vertical translation. You can look at your vertical stretch or compression. But there is a way to get the vertex without completing the square, and that's what this example is about. So if you guys remember, we have this negative b over 2a, so you probably remember this a little bit from Algebra 2. But this is the x value of our vertex, or this would be like our h, right? And then this would be our k. All right, and to get the k, we're just taking this x value, which is h, we're taking that, and we're just plugging it into our function to, get the y value of the vertex out. So we have first this quadratic function, and in order to know if it opens up or down, we're looking at this leading coefficient here, and anytime you have a negative in front of the function, we know that is a reflection over the x-axis, so this is going to open down. And then to get the vertex, we are going to use this negative b over 2a to get the h value of the vertex. Okay, so h equals negative b over 2a. Well, a here is negative 1 and b is negative 4. So what happens is we get the opposite of b over 2 times a. And what I would suggest is take a look at the numbers first. This is really just 4 divided by 2, so that's 2. But I have 1, 2, 3 negative signs, so I know this is going to be negative 2 when all is said and done. So to get the k, we are just going to evaluate f of our h value, of our x value of the vertex. So that is going to be the opposite of x squared minus 4x. And our x here is negative 2. So then this equals positive, this is going to be positive 4, but we have the opposite of that positive 4, so this is negative 4, and then negative 4 times negative 2 is positive 8, so then we're left with 4. So our vertex is negative 2, 4. The axis of symmetry is just the x value of the vertex. So again, remember it's a vertical line, the equation for a vertical line, so it's just going to be x equals negative 2. And now we're going to draw a sketch. So if we're going to be drawing this, all right, we have our vertex. So we come down and we go negative 2, and then up 4. All right, and notice this leading coefficient a, it's 1, and what that means is we do not have a vertical stretch or a vertical compression. What we have is the parent function, and that's great. We do know there was a reflection, so instead of going up, we're going down, but we know for a quadratic, or for x squared, our square function, we just go left 1, down 1, right 1, down 1, left 2, down 4, and then 5, 6, 7, 8, 9, so 3, and then down 9. All right, so now we have our function here. Okay, and again, x equals negative 2, that's this guy right here, that line, that's our axis of symmetry. All right, so then it wants to know the y-intercept. And again, for y-intercept, if you're trying to solve for the y-intercept, we need x to be 0. All right, so when that happens, we get y equals negative 0 squared minus 4 times 0, which is obviously just 0. So then we get when x is 0, y is 0. All right, but for the x-intercepts, we're going to let y equal 0. So we have 0 equals negative x squared minus 4x. You're more than welcome to do the quadratic formula or complete the square. For me, I'm just going to factor the greatest common factor. So I'm going to pull out I'm going to go ahead and pull out a negative x. If you pulled out a positive x, you would end up with the same answer. And when we divide, we get a positive x plus 4. So using zero product property, I get negative x equals 0, x plus 4 equals 0, so x equals 0, and x equals negative 4. But when does x equal 0, negative 4? When y is 0. So these are our intercepts, negative 4, 0, and 0, 0. And if you graphed it right, you can go ahead and check, and you'll notice that sure enough, these are our two x-intercepts, and then this is our one y-intercept. Domain for all quadratics or all real numbers. Remember, the only restrictions on domains are going to be even roots, and then if you have an x in the denominator, so rational functions, and then later on when we get into logs, we'll also have some restrictions. For the range, however, we do have a maximum here, so we have a highest point, and that highest point, the value of y is 4. So our range from bottom to top is going to start at negative infinity, and it's going up to 4. That is inclusive, so you want to make sure to put a bracket. And then increasing and decreasing for quadratics are always around the vertex. Okay, and anytime you're talking about increasing, decreasing, you're only using the x value. So I know that this negative 2 is involved, and it's increasing from negative infinity to negative 2, and it's decreasing from negative 2 to infinity. Again, make sure you do not use brackets for this part, because anytime you're talking about increasing, decreasing, this turning point is never considered increasing or decreasing. Okay. And so that is how we use this negative b over 2a in terms of graphing the function and getting everything. But I do just want to review real quick, if you were to complete the square, what that would look like and compare that to our graph here. So for completing the square, and then this can give you an idea of like which method to use, like whether you would rather use the negative b over 2a or whether you'd rather complete the square. All right, so we have negative x squared minus 4x equals y. All right, so y equals this. I'm going to have to eventually add something to both sides. Okay. Anytime we have a leading coefficient other than 1, we're going to factor that out. So I'm going to pull out this negative 1, and we get x squared, and then plus 4x plus some number that I don't know yet, equals still y plus that same number. And now that I factor that out, now that the leading coefficient is 1, now I can complete the square here. So to complete the square, if you recall, we're going to take half the middle term, so half of 4 is a positive 2. We square that and we get a 4. All right, however, we need to redistribute this. So again, it's really negative x squared. It's really minus 4x, and this is really going to be minus 4 here. But what you add to one side, you add to the other. Okay, and then so then we have the opposite of x plus 2 squared equals y minus 4. Now I want to solve for y to get my equation. So we have the opposite of x plus 2 squared. If we add 4 to both sides, all right, this is what we have. This negative on the outside of my parent function x squared. It's on the outside, so that is a that is a reflection over the x-axis, and then this means left 2, and this means up 4. And if we take a look, sure enough, this was reflected over the x-axis and moved left 2 up 4. So so this is more from like our unit 2 when we had our parent function, and you could easily see the translations and the reflections, and that's, you know, and it's nice. So completing the square is a really great way to have the equation, but we were able again to graph this just by getting the vertex and looking at the leading coefficient.